Okay, this is a little homework help for lesson 3.6, page 205, and we are using the quadratic formula to solve quadratic equations. So here's number 14. The first thing that has to happen is this negative 200 needs to be added to both sides because we need to put this in a standard form equal to 0 before we get into the quadratic formula. And just in case you don't remember the quadratic formula, I'm going to write it up here. The opposite of b plus minus the square root of b squared minus 4ac all over 2a. All right, so let's plug in. X is going to be equal to the opposite of b, so that's going to be negative 45 plus minus the square root of b squared. So we need to grab our calculator and let's see what 45 squared is. That's 2025 minus 4 times a, which is 1, times c, which is now it's 200. And we'll come back and simplify all that in just a moment. All of that goes over 2 times a, 2 times 1 is 2. Okay, so let's simplify underneath the radical, and we have 2025 minus 800. And that is 1,225. Okay. And let's see, is there a perfect square root for 1,225? I believe there is, and it is 35. So the square root of 1,225 being 35 turns our formula into this. Now at this point, since we have all integer numbers that can be combined, we don't want to stop at this as a final answer. We want to go ahead and come up with the two solutions. For example, what is negative 45 plus 35? So it's really, we're going to be doing this. Negative 45 plus 35 divided by 2. That's going to be an answer. And then we're going to do negative 45 minus 35 divided by 2. Okay, so negative 45 plus 35 is negative 10 divided by 2. That's negative 5. That's one of my solutions. Here I'm going to get negative 80. Negative 45 minus 35 is negative 80 divided by 2, and that's negative 40. So the big reason why I wanted to do this problem is from time to time I have people that stop here. And when it's possible to combine these, which it is now in this case because these are just integer terms, you need to go ahead and come down to a final answer which includes two numbers. All right, so that is your final answer for number 14. Let's try number 18. Number 18 also needs to be rearranged because it's not in standard form. So we need to subtract 11x from both sides, make it equal to 0. Okay, now we're ready to jump into the quadratic formula. So the opposite of b would be 11 plus minus the square root of b squared. Negative 11 squared is 121 minus 4 times a times c. Just going to write all those out, and then we'll come back and simplify. And all of this is going to go over 2 times a. A is 5. Okay, let's clean this up a little bit. So under the radical, and you really want to be careful here, I see mistakes made when people are subtracting negative numbers. So just be very careful. When you subtract here, this is, we're subtracting 20 times negative 9, which is negative 180. Okay, so if you need to, just for organization's sake, you might want to put brackets around the part that needs to be multiplied together, and that's 20 times -9. And we're going to be subtracting that, of course, which means addition. And all of that goes over 10, 2 times 5. All right, we're making our way through. If we do 121 plus 180, I think that's 301. Yep, so we have the square root of 301 all over 10. Now at this point, there is no perfect square root for 301. There are no perfect square root factors of 301. So in other words, there's no way to simplify the square root of 301. There is no way to reduce, obviously, because I would have to be able to divide into all three of these numbers by something other than 1. And that's not possible. So as it turns out, this is going to be my final answer for number 18. All right, so there's two examples of solving by using the quadratic formula. And now, on starting with number 21, the directions changed a little bit, and we're going to just do parts A and B like we did in class. I want you to find the value of the discriminant first, and then I use the word interpret that number into what does that mean as far as the number and types of roots that we're going to have. So I feel like we've already practiced enough with quadratic formula, so I'll save you a little bit of time and you can just do parts A and B on 21 through 32. So the first thing that has to happen on number 28 is obviously this 9 needs to be moved to the left side. All right, so now we're ready to evaluate the discriminant. And remember, the way we find the discriminant is just doing this part of the quadratic formula, just the part that's under the radical. So b squared would be 36 minus 4 times 1 times 9. So 36 minus 36 is equal to 0. So as we mentioned earlier, there's 4 possibilities. First of all, that's your answer for part A. The value of the discriminant is 0. Well, part B says, well, what does that mean in terms of the number of solutions or roots, and what kind are they? Well, if the discriminant is 0, that means we're going to have one rational root. To put it in terms of graphing, that's like saying we're going to have a parabola that has the vertex sitting on the x-axis. We're only going to have one x-intercept, and that's going to be the vertex. Okay, so that's the complete answer. The only 2 parts, you can, if you want to go ahead and do C for practice, that's okay, but all I'm going to require you to do is parts A and B. Okay, so that's your answer for number 28. So let's take a look at one more. Number 30. It also needs to be arranged into standard form. So I'm going to add 4x and make sure you put the terms in the proper order. Quadratic term, then the linear term, then the constant. So first of all, let's find the discriminant. B squared minus 4 times A times C. B squared would be 16 minus 4 times A times C. Okay, so we're going to be doing 16 minus, and let's see in our calculator, what is negative 32 times 5? That's negative 160. Okay, so I'm subtracting the product of these 3. Okay, and subtracting a negative means adding, so we end up with a discriminant value of 176. All right. Well, part B says basically, what does that mean? How many solutions are we going to have, and what kind are they? Well, it's a positive number, so we are going to be crossing the x-axis twice. But it's not a perfect square root number. 176 doesn't have a perfect square root, so that means the square root of a non-perfect square number is always going to be irrational. So my answer for letter B is I'm going to have 2 irrational roots. Okay, and that's it. Those are the only 2 parts that I'm going to require. So I hope that helps you with the rest of the problems you have to do. If you have any questions, you're welcome to email me or come see me in academic support.